Hello everybody, glad to see you. Today we're going to talk about concentricity. As we can see here at top right, we are going to have this symbol. In first example, we are going to implement it, this concentricity symbol. In this FCF, TZ is 0.5 back to A. A is axis of this cylinder. We are going to have a cylinder with a diameter of 0.5 and we are going to calculate where is the location of midpoints for opposed points in each cross section. In each cross section, we are going to have many points. We are going to calculate the midpoints for each opposed points. All points should be in that TZ. Each cross section is going to investigate individually because we are going to use this concentricity. And it is time consuming and it is not easy to calculate that one. That's why, based on ASME 14.5 2018, we should not use any more concentricity symbol. It is really good to find the mass distribution. As we can see in second example at bottom, we are going to have this component. In order to see the mass distribution respect to this axis, let's say A here, we can use this symbol to see the mass distribution. TZ is 0.5 back to A. A is axis of this cylinder. And we are going to calculate the center point for each opposed points. That center point should be in that TZ, cylinder with a diameter of 0.5. Here we are going to have the last example for concentricity. We have TZ 0.01 and back to axis Z. For each cross section, as we can see here at bottom, for each cross section, for 2 points, we are going to calculate where is the location of midpoints. That midpoint should be in the mentioned TZ. We are going to check the location of center points or median points. And please don't use it. Let's talk about runout. We are going to have this symbol as we can see at top right. For each rotating component, it is really good to have this runout symbol to check the form and orientation of that rotating component. As we can see here, this runout has a TZ 0.2 back to A. A is the axis of this cylinder. In this manner, we are going to rotate this component around that axis, and this dial indicator should not move more than 0.2. Here I have highlighted this L over D ratio, this length of this cylinder and diameter of this cylinder, in order to be in a way to rotate this component around that axis. Here we are going to have another example. In second example, we are going to have run out TZ 0.03 back to A. A is axis of this cylinder, and we are going to have two concentric circles, and for each cross section, the form of that circle should be in that interval. We are going to control the surface, let's say form and orientation of that cross section. We are going to check for different cross sections individually, and we are going to check the form for each cross section individually. Let's see this example. We are going to use this runout TZ 0.5 back to AB. As we can see, the length of this cylinder is short and the length of this cylinder is short, but the distance between these two A and B references is long enough. That's why it is good we can rotate this component around AB axis. For each cross section, we are going to have two concentric circles, and the TZ is 0.5, and the form of that cylinder should be in that interval. In this manner, we are going to control the orientation of that cylinder as well. But keep in mind, these cross sections are going to check individually. Let's see this example at bottom. We can see it is run out symbol, TZ is 0.5, back to AB axis. It is going to point this surface. It means we are going to check, let's say, flatness, perpendicularity, or wobbles for that cross section. It should be in this TZ 0.5. For different cross section, we are going to check it, and these cross sections are independent. Let's see this example. We are going to have run out TZ 0.75 back to A. We are going to rotate this component around A, and dial indicator is here. We can check the form and orientation of this cylinder for each cross section individually. Let's see this example. We are going to have, let's say, round out TZ 0.1 back to AB. We are going to rotate this component respect to AB axis, and for each cross section individually, we are going to check the form and orientation of each cross section. At bottom, we can see here it's going to refer to this surface. We have run out 0.1 back to A. We are going to check flatness, perpendicularity, wobbles for each cross section individually respect to datum axis A. And here we are going to have a conic shape, and we are going to use this, let's say, round out TZ is 0.1 back to A. As you can see, this dial indicator should be perpendicular to that surface. That's why for each cross section, we are going to check, let's say, cylindricity or concentricity for this example, as we can see here. For the last example for today, we are going to have this example, this run out here, TZ is 0.75 back to A and B. We are going to have this gauge here, and we are going to rotate the component around AB axis, and dial indicator is here. We are going to control the form and orientation of this feature respect to AB axis for each cross section individually. Now I would like to close this session. In coming session, again, I'm going to talk about the round out. Thank you for today. I hope you enjoyed. See you next time.